All right, we're going to get started today. So welcome everyone to Kubernetes Costs More Than Meets the Eye, Strategies for Effective Kubernetes Cost Optimization. Thank you all for joining us. I'm just going to go through the agenda and quick housekeeping and introductions. So we're going to talk about, obviously, Kubernetes costs, resource efficiency, how autoscalers play a part, some best practices and strategies, beyond some tools. We'll do like a quick demo of the new Commodore cost optimization features, and we'll open it up at the end for Q&A. So yes, this webinar is being recorded, as you probably heard. For that Q&A section, you're welcome to use the Q&A button on the bottom of your Zoom screen. And you can ask questions, and then we'll get to them at the end. The webinar today will be about 45 minutes long, give or take a few minutes. And let me quickly introduce our speakers. I'm, by the way, Ilan Adler, Product Marketing Manager at Commodore. With me today is Kelly Friedman, Regional VP of Enterprise Sales, and Phil Edwards, a Solution Engineer from the Commodore Solution Architect team. Welcome, Kelly and Phil. Just say hi, so I know you guys are there.
Hello.
Hey.
Good morning. Good afternoon, everybody.
All righty. And having said that, just before I hand it over to Kelly for the bulk of presentation, we're going to do to see where people are standing. We're going to do a quick 30-second poll. I'm going to launch the poll right now. And the poll, as you see, is what is the biggest contributor to Kubernetes cost overruns in your organizations? And I'll give that like 15 more seconds for people to answer. Obviously, spoiler alert, a lot of the things are things that we see in the field and we're going to talk about today. And a few more seconds. So I'm going to end the poll. What we saw, 40 people, 40%, excuse me, incorrect or poorly configured resources, requests, and limits. And the rest were 20% for each of the inefficient scaling, idle and unused resources, lack of visibility into what teams can consume which resources. Pretty in line with what a lot of customers and prospects share with us during calls. And now I'm going to hand it over to Kelly Freeman for the rest of the presentation.
Juan, thank you so much. This is a question that we ask ourselves a lot and we hear each other ask quite often. Why the heck is my bill so large? Let's talk about that. Let's start off by zooming out a little bit. Why are Kubernetes bills getting out of control? Static capacity planning is not working, especially in a world of dynamic workloads. You've got CPU bound, memory hungry, and short-lived pods that are all in the same cluster. And when teams tend to over-provision just to be safe or reuse outdated configurations, it leads to two common outcomes. Number one, over-provisioning, where you're paying for resources that are just sitting there idle, which is not great. Or number two, under-provisioning, where you're crashing under traffic spikes, which also isn't great either. So the end result is inefficient bin packing, wasted capacity, and a cloud bill that's really hard to explain, let alone justify. The requests and limits are often guesswork. Admins say things like, man, we're overspending. If you go back just one more, I'll let you know when to advance on. Thank you. Requests and limits are often guesswork, and admins say things like, we're overspending, but we don't know where, or we can't justify Kubernetes cost of finance. This is what FinOps Foundation calls the visibility gaps. So when engineers make allocation decisions with zero cost context, there's a gap that we're here to close. So the Kubernetes resource efficiency problems. Yeah, Kubernetes is powerful, but its cost efficiency relies on how well you understand and you configure it. Resource limits and limits often feel like educated guesses. Teams are either over-provisioning just to be safe, or they're under-provisioning and they're dealing with instability, which isn't good. And this isn't just about spend. It's about performance risk. The FinOps Foundation calls this the engineering cost disconnect, where decisions made at the pod level have major financial implications, but zero visibility to the people that are actually footing the bill. Our job is to help close that gap. Defaults are inefficient. No one knows what's actually needed. What this all adds up to is waste, a waste in time, a waste in compute, and a waste in budget. And the big kicker, most of the performance issues stem from a lack of context. So we're not just fixing a spend issue, we're actually fixing an observability and an ownership issue as well. Next slide, please. So we've spoken to a lot of Kubernetes admins over the years, and we've learned a couple of things and some feedback that we've been getting. We're overspending, but we don't know where to cut. Or just as important, we can't justify our Kubernetes cost of finance. We hear that quite a bit. And thirdly, and just as important, is the resource requests and limits are basically guesswork. So provisioning is usually based on outdated assumptions and defaults are often go untouched. The outcome? Increased TCO or total cost of ownership, poor user experience for both your internal and your external customers, and an overloaded teams dealing with performance issues without real context. Next slide, please. So it's not just your platform team that are raising the red flags, though. It's also the analysts, organizations like Gartner and IDC and others that have spotlighted Kubernetes cost visibility and control as a top priority. And research is showing that organizations waste 30 to sometimes 40, even 50% of their Kubernetes spend. Not because they're doing something wrong or they're doing something nefarious, but because they're missing insight, they're missing context. But if we bridge that gap, we don't just save money. Again, we're improving reliability, we're improving performance, and just as important, we're improving team velocity. So these aren't just one-off complaints. They're systemic issues that run across all industries and all verticals. Next slide, please. So let's transition for a moment, if we can, to the concept of autoscalers, and a concept that's really changed how many teams scale. Tools like Carpenter are dynamically provisioned and they decommission nodes based on pod requirements in real time, which is great. They improve bin packing, they select optimal instance types, and they can leverage spot versus OD or on-demand based on performance and trade-offs. Autoscalers were a big leap forward in Kubernetes efficiency. But as we'll see next, they're not the full solution. Next slide, please. So let's talk about what autoscalers like Carpenter actually do well. They're dynamically provisioned. They terminate nodes based on real-time pod requirements. They select instance types intelligently, reducing wasted space. And they also leverage different instance lifecycles like spot versus OD or on demand to balance cost and reliability. These are huge gains, and many teams see significant improvements just by adopting tools like Carpenter. But while autoscalers are great, they're not enough on their own. Next slide, please. So it's important to remember that autoscalers can only optimize what they're told to optimize, and most teams are feeding them bad data. If the workload is oversized, Carpenter will still replace it, but it doesn't evaluate whether that pod needs 4 CPUs or just 400 millicores. And therein lies the challenge. So if it just doesn't account for bin packing friction, evictions, and performance instability caused by poor scheduling policies, to truly optimize, we need visibility and control beyond autoscaling. And that's where Commodore steps in. Next slide, please. So now that we've seen the limits of autoscalers alone, let's talk a little bit about what real Kubernetes cost optimization looks like. It's not just about cutting spend. It's about aligning performance, aligning efficiency, and visibility. And to do that, we need more than just node scaling. We need smarter workload management, right sizing, and bin packing that actually works in the real world. It's optimization that actually sticks. No regressions, no one-size-fits-all templates. Next slide, please. So visibility is really the first step in any cost optimization strategy. Commodore gives you the ability to track infrastructure, cost by cluster, by namespace, by application, or environment. You can actually filter by team, zoom in on the anomalies, and tie financial data directly back to engineering action. This isn't just about numbers. It's about empowering teams to make smarter decisions with real-time feedback. And when developers see the impact in dollars and cents, accountability becomes automatic. It actually becomes a natural course of action. Next slide, please. So as Commodore continuously analyzes real-world uses patterns, whether it's CPU, memory, throttling, and scheduling, it will actually make precise resource adjustments in real time. And this right sizing isn't just based on assumption, it's based on fact. It's based on live behavior. So teams who have implemented this have seen anywhere between a 30 and a 50% reduction in cost without sacrificing reliability or performance. It's really the difference between tuning for hope and tuning for reality. Next slide, please. So as Commodore actively improves bin packing by grouping non-evictable workloads and placing pods based on scheduling constraints like affinity rules, PDBs, and resource limits, this reduces unallocated capacity and really unlocks autoscaler-driven consolidations. As I mentioned before, and again, it's not about saving money. This is about creating conditions for efficiency scaling and high reliability. Next slide, please. So let's break down Kubernetes cost optimization evolution and how it's evolved. Moving left to right across this visual, on the left, we have environments with neither Carpenter nor Commodore. It's almost like a DIY environment. This is a manual zone, static provisioning, no visibility, and constant firefighting. Teams rely on guesswork and over-provisioning to play it safe. The result? High cost and unpredictable performance. As we move to the right in the middle, you see teams using Carpenter alone. And this adds auto-scaling to the mix, better bin packing, lifecycle awareness provisioning, and some cost improvement. But Carpenter doesn't address workflow inefficiencies. If a pod is oversized, it's still placed, just more quickly. And on the far right, what you see with Commodore is things really change. Now, workloads are right-sized in real time. Pod placement is constraint aware. Non-evictable workloads are grouped intentionally, and autoscalers can consolidate effectively. This is full stack optimization. Cost, performance, and reliability working together, not just against each other. Next slide, please. So now what I'd like to do is bring in someone who's been helping enterprise customers operationalize this every day. Phil Edwards is a senior solutions engineer here at Commodore. He brings years of experience helping engineering and platform teams get the most out of Kubernetes, both from a technical and a business perspective. Phil's going to speak briefly about best practices, and then he's going to take us into the demo and show you exactly how all this comes to life in the Commodore platform. Phil, over to you.
Thanks, Kelly. Go ahead and get the next slide, please. All right. So of course, as Kelly has been talking through cost optimization, and one thing that is very relevant and top of mind for me is cost efficiency is very paramount, right? Of course, we want to be cost efficient, we want to be resource efficient, we want to spend as little money as possible, but there are sets of best practices and strategies that are really going to be in place, things that we can put in place that are going to not only help us attain those efficiencies, but also help us do it intelligently, under control, so that it is a reasonable and thing. Ultimately, our cost efficiencies are controlled as we expect them to. So these four these four best practices as we look at are things like setting guardrails, maintaining auditability, adopting a holistic approach, and correlating cost and reliability are all ways that we can gain those efficiencies, but also protecting our compute layer, protecting our applications as they run on Kubernetes. So we'll see how these things can be done through Commodore once we get into the demo. But when we look at setting guardrails, we're talking about ultimately using policies and automation to list or to limit risky manual changes and enforce best practices, right? We can set policies that we talk about, wanting to allow Commodore to automatically attain efficiencies through things like limiting how much we can right size a workload. This can protect us, of course, to protect us from the problems of under provisioning. Doing things like maintaining auditability and control. It's great to have automation in place. It's great to see recommendations and for how we should be making changes to our right sizing. But of course, we need to have something. We need to have auditability. We need to have something that is logged. We need to have some traceable to understand where and how our resources are being impacted, right? These auditable events should be done both for manual and automated approaches for your team. Right, and moving on to a holistic approach, cost efficiency, performance, these are things that should be adopted as in an organization. No single team should be responsible for this. We should work to limit silos, and this means a platform team taking cost estimate numbers and throwing it over the wall to their development team and saying fix it. That's unlikely to actually do anything, right? Other than just waste everyone's time. So adopting holistic approach, using things where all teams have a stake in attaining efficiencies are the way to go. And then lastly, and certainly not least, correlating cost and reliability. So cost and performance really are two sides of the same coin. This goes into the over provisioning and the under provisioning problems that can you can get this flip-flopping approach, right? We right size a workload, we go too far, we start to impact the workload with some reliability issues, and then also followed by setting our requests and limits back up higher. So let's go ahead and move on to the next slide. All right, so now we're going to go ahead and jump into the Commodore platform, and we're going to walk through the cost optimization features that the Commodore platform now has. Before we do that, we do have I think 3 or 4 slides that we're going to briefly walk through. I do want to spend most of the time inside of the product, but let's go ahead and go to the next slide. So when Kelly spoke a lot about the cost challenge with Kubernetes in general, right? And of course, we're going to now be talking about those challenges and ultimately how Commodore can solve those. And so the first thing that we start is purely getting visibility into your spend and allocation. Cost visibility is going to, of course, be looking at your overall infrastructure costs, looking at things like they evolve, and you might be thinking, great, well, I can just go to my cloud provider. And sure, that's a lot of ways true, but I think the one of the main things that we're going to be looking at as to how Commodore can increase the usefulness of cost visibility is being able to break this down by things like namespaces or clusters, or break it down by things like based on annotations or labels inside of a workload. And then when we think about those real costs and real time, right? Maybe your organization operates in an on-prem solution, or maybe a multi-cloud solution, right? There's no real easy way as of right now to be able to control those costs or look at those costs across all of your different hosting providers, and that's not even including things like discounts and usage-based pricing and so on and so forth. Let's go ahead and go to the next one. And so once we get into how Commodore can really start to help with these things, we're going to be looking at a couple of things, and we're going to be looking at workload right sizing first. And so this really is looking at the things on the right, being able to intelligently optimize our resources through Commodore, analyzing CPU, analyzing memory, throttling, scheduling, all of these different things that are available inside of a cluster. Being able to account for what the actual workload needs so that we do not get into an over provision or an under provision scenario. We get right in the middle. And this is, of course, Commodore is not just a cost optimization tool, but very much a reliability, a troubleshooting tool, in addition to focusing on costs. So we know with Commodore, we're going to be able to ensure that our applications are maintaining that resiliency, that we're being good citizens and avoiding things like throttling, evictions, and other scheduling failures. And then the last thing we think about is when we're talking about autopilot mode with guardrails. I think automatic right sizing is something that many organizations look at and see as a great way to ensure that they're being cost efficient. But at the same time, we have to have guardrails in place to ensure that our automation is not doing things that we do not expect, right? And this comes with setting things like min and max thresholds, change frequency caps, buffer windows, all things that can be put into place from a policy point of view to allow Commodore to safely and securely automatically right size our workloads and ensure that we don't hit any unexpected things. All right, let's go to the next one. All right, and the last thing we're going to talk through is we think about bin packing. And so Kelly gave a great description of bin packing and ultimately what Commodore can do, how Commodore can um, increase the capabilities of cluster autoscaler and Carpenter specifically to ensure that we have a much more um, intelligent placement of our different pods. And so this is where we get into bin packing. Now, bin packing, of course, is something that is going to help from a purely node point of view. But when we think about what it actually does for a cluster autoscaler or something like Carpenter, we now allow this intelligent pod placement or pod spread allows the autoscalers to freely scale up, but more importantly, scale down when we hit something or when we hit a scenario where we can scale down. This comes with things like ensuring that we don't run into unevictable pods on nodes that we're trying to get rid of. Going to go to the next one. And then, we think about headroom, right? Headroom is something that Carpenter doesn't support natively out of the box, right? You can employ various um, solutions inside of Commodore to trick, I'm sorry, eh, you can employ various solutions with Carpenter to trick Carpenter into doing things such as providing headroom, but via Commodore, we're able to explicitly state that the conditions in which we will have headroom to ensure that we don't run into cold starts or things like waiting for a node to be spun up to add pending pods. All right, I think that is the last slide, if I'm not mistaken. All right, so what we're going to do, correct me if I'm wrong, but we want to do question and answer after the actual demo, right? Okay, cool.
Yes,
So
sir.
let's
That's
go ahead
correct.
and do that. And I will go ahead and share my screen. All right. And apologies for the Zoom windows while I get them out of the way here. Okay. Okay, so what we're now looking at is a demo environment inside of Commodore. And for folks that are familiar with Commodore, you'll now notice that there's some new a new cost section with some new pages inside of that cost section. And so this is where we look at, and of course these things are not generally available, so you'll likely not see them inside of your Commodore account if you log in and check. However, excuse me, we are going to walk through these 4 pages to give you guys an idea of what's new and how they can ultimately be utilized to attain those cost efficiencies. So first and foremost, we have a cost overview page, and this is where we're going to be given some high-level metrics, of course, talking about things like real cost, how that's broken up into allocated, meaning compute that is actually requested by workloads across your Kubernetes estate, and also unallocated spend. So things where idle resources essentially on nodes that are not allocated. We're going to be given some monthly active savings where we can see both what are actually Commodore's right sizing and optimized pod placement or bin packing. What are those solutions actually providing for us on a monthly basis? And then lastly, right, we're going to see a potential savings. And so this is also going to be things where maybe we don't have automated right sizing configured for a set of workloads. You can see, right, this potential savings of almost $36,000 for right sizing. These are where we do not have automated right sizing enabled. And then lastly, right, we can see what further can Commodore provide for us from a bin packing or an optimized pod placement. I think the last things I'll talk about, we're going to jump into this allocation or here in just a second. But when we look at the cost trends, obviously having a graph that's showing us over the last 30 days or 60 days or whatever, and being able to see that trend to the right and trend down is of course what we're looking for if we are looking for cost efficiencies. And then the last two things that I'll figure or that I'll talk about here is, of course, right. It's good to know that Commodore can provide real costs, but there are certain scenarios in which Commodore just does not have the ability to understand your real costs from a cloud provider, or maybe you're in an on-premise situation. And so this is where things like pricing discounts and setup for those things can can be inputted into Commodore to ensure that we can track things like different costs for cloud providers, or maybe you have reserved instances, or maybe you have some sort of discount plan with your compute layer. And then lastly, right, we're also going to have the ability to configure headroom through various means into Commodore. So let's go ahead and jump into our allocation, and let's see what Commodore is going to be providing. And this is, that we were looking at that previous 30-day graph. This is more or less that same graph, right? But we're going to be getting a much more granular view into what actually makes up that cost. And these are things that are of course largely it is a report. But when you think about the capabilities or the possibilities here, you can see, as Commodore is able to break these down by things like cluster, and we can even go further as far as namespace and even down to this individual service level. We can very easily, either through the Commodore API or through exporting of this data, be able to facilitate it out inside of our organization to ensure that whoever is responsible for these various workloads understands where those efficiencies are to be had. Of course, this assumes that Commodore automatic right sizing is not actually turned on. Now let's go down to the right sizing part. The right sizing and the pod placement, right? These are some very exciting things where we're now talking about how does Commodore automatically help us attain those cost efficiencies or those resource efficiencies, right? These are things that can automatically impact the bottom line for our organization and ultimately save money. So when we think about the right sizing portion, of course, we're talking about Commodore in the automated side of, or in the automated case, being able to look at, I'm going to go towards the bottom here, being able to look at our active savings, right? This is our automated, we see autopilot with guardrails, where Commodore is actually automatically right sizing these under the guardrails or the conditions that we have specified. And so this is how we can be sure that our workloads are automatically being right sized the proper way, the most efficient way, so that we are, one, being cost efficient as possible, but two, we are also not incurring any sort of reliability point of view. So these active saving ones, this is going to be that auditability point of view, where you can come in here and see these are the changes that Commodore is making. This is the money that Commodore is saving for us to ensure that there's transparency throughout. And then thinking about the potential savings here, right? We can now look at, hey, great, we're automating a certain point of our right sizing, but there's still a portion in which we have a lot of gains to be made. And there could be some scenarios in which your organization doesn't want to enable it. Maybe it's an extremely critical service in production, and you have reservations about automatically right sizing. And those things they're understandable, but that's also why we've put these guardrails in place. So how would we go about setting up this from a potential savings to an active savings? You can see, again, folks that are familiar with Commodore, you'll see this should be a familiar screen, right? This is Commodore showing from a granular level what our containers are using from a requests and limits point of view for CPU and memory, and then the recommendation for what is Commodore actually stating, or what is Commodore saying that these workloads should actually be using from CPU and memory point of view. One thing I do like to point out, if we look at this cost optimization strategy in the upper right hand, is Commodore is you can alter how aggressive or conservative Commodore is with these recommendations. And so this is another lever that organizations can use to ensure that they're comfortable with the amount of automated right sizing that Commodore can take. The last toggle that we have here at our disposal is to actually enable our automated right sizing. So if I so wish to do that, I can pop in here. I can edit my policy, but I can also ensure that the policy or the guardrails that I have put in place is what I expect, right? We can see that the recommendations will only be applied when the pod is created or restarted. This is a critical idea to understand, right? If your I think it's version 133 of Kubernetes that now allows in place resource resizing without a pod restart. But if you're not on 133, this is an important thing to understand, right? We do not want to just automatically restart a pod just because we want to resize the request. So this is something that could potentially be the proverbial foot gun, right? And shoot ourselves in the foot by causing some application degradation. We're going to be able to understand what do we want Commodore to manage? Do we want Commodore to just work on requests? Do we want Commodore to only manage CPU, right? Do we want to only do memory? All of these things are configurable. We can allow Commodore to right size up, right? So this is we're talking about cost efficiencies, and cost is the topic of this conversation. However, there is still a chance that Commodore might detect that we have CPU throttling or something like memory pressure, right? And so allowing Commodore to scale up both of those resources can be a critical thing as well. And then the last two things, right? We're going to be talking about what constraints do we want to put in place for right sizing. Do we only want Commodore to be able to go up or down by 20%, or based on the last change, right? Really, again, to provide these guardrails to ensure that all people are comfortable. And then last but certainly not least, right? What do we want to allow to Commodore to have as a buffer? There are certain types of workloads that are maybe once a month, get a lot of traffic, maybe once a quarter. Through these guardrails, right, we can build in those tolerances to ensure that Commodore doesn't overly optimize something. Okay, and so the last, but certainly not least, page that we're going to be talking about is our bin packing or pod placement, intelligent pod placement. So this is obviously a similar view to what you're seeing. We're talking about potential saving. We're just talking about active savings, and we're also going to be looking at how much of our workloads or how much of our clusters are actually automated or set up for intelligent pod placement. The last graph that we're there, or the last graphic that we have of it at our disposal, is being able to understand allocation and capacity over the last 30 days, which is obviously important to note. We do have the same type of breakdown of potential savings and active savings, with the potential savings being, what can we attain by enabling intelligent pod placement. And you'll generally notice, if we look at this unevictable pods, right, with a high level of unevictable pods, this is usually a really good sign that intelligent pod placement is going to be very good for an organization. If there is not a ton of unevictable pods, that generally means that, although this is not always true, that generally means that something like Carpenter is set up to work very well and should be pretty efficient inside of an organization. And the last thing I will talk through, of course, is this active savings pane. So again, this is another way to have that auditability to understand where is intelligent pod placement enabled, and then, of course, what is intelligent pod placement doing for us organization? How much money is it actively saving? Because these are really the things that we want to know as an organization, is not how much money have we spent, but how much money have we saved. So with that, I will go ahead and stop sharing screen, and I believe we have time for Q&A.
Yeah, thank you so much, Phil. That was fantastic. We have a couple questions from the audience, which I'll get to, and I think you'll be able to answer them well. So one, and this is at the core of what we talked about, like with Commodore and autoscalers. One of the questions was how can you compare Commodore with HPA, horizontal pod autoscaler, and VPA? Please, vertical pod autoscaler. Can you explain more of where Commodore stands, like in accordance to those in what we've shown today?
Sure. So I think when like probably the biggest distinction in my mind is when we're talking about horizontal pod auto scaling or vertical pod auto scaling, we're usually not talking about things like directly, at least, about node autoscalers. So when we think about intelligent pod placement or bin packing, right? We are talking largely about tools such as cluster autoscaler or Carpenter, where node autoscaling is being employed rather than just increasing the replica count in the case of HPA or decreasing, or in the case of VPA, where we're talking about increasing or decreasing the resources directly of the pods themselves. So there's no real, I won't do a comparison. I think Commodore and the cost strategies that we've talked through do not invalidate HPA and VPA by any means. I would state that they actually can work together, especially VPA, right? And when you think about automated right sizing, that's ultimately kind of what we're doing. I think one thing to note is there are definitely considerations to take in mind when you're talking about HPA versus node autoscaling, such that you want Carpenter to be aware of such things, and same goes for cluster autoscaler. But I think they're kind of back to it. HPA, VPA, and what Commodore is doing for costs are ultimately complementary.
Excellent.
Hmm.
And then Robert just asks another question, and this is you also be the one to relevant.
Sure.
How does Commodore make our decisions on, is it metrics from a metric server, or do we integrate with additional like monitoring platforms? Like how do we actually make those right sizing, for example, decisions, or the decisions with the pod placements for the autoscalers?
Yep. No, this is a good question. So, as Commodore, part of the Commodore solution is an agent deployed into each cluster that's onboarded to Commodore. So, absolutely, right. Getting metrics from metric server via the daemon set component of our agent is 100% the start of how Commodore makes these decisions. Tracking CPU and memory usage of each workload over a historical time. Think 30 days, 60 days, 90 days. Looking at what are the actual requests and limits set inside of the workloads manifest. Then also understanding things like scheduling signals, right? Looking further into just patterns inside of the cluster itself. Those really are the way, or the pieces of data that Commodore will use in order to understand when something needs to be right sized up or right sized down. I think when we think about right sizing up, of course, we're talking about, hey, if Commodore is detecting that there are things like CPU throttling events, say a deployment, for instance, Commodore detects is being throttled for 70% over a period of few hours, right? This is a very good signal that this should be sized up. Commodore will take all of those other variables into account, but ultimately make the appropriate step and right size the workload up.
Awesome. Thank you so much, Phil, for the wonderful demo and the and taking thoughtful answers. We're just almost out of time. Kelly, do you have anything else you want to say before we sign off? Any parting words on your end?
Looks like we've got a couple more questions up, which
Oh, okay.
I
Missed
can
it.
Yeah.
I can walk through
Yes.
them.
Oh,
Yeah,
okay.
absolutely. So can auto scaling work with GitOps deployed workloads where systems such as Flux or Argo would keep fighting? This is a great question. And so I think there's two things to think about here. One, right? So one thing, Commodore is going to be adjusting when we talk about automated right sizing, right? Commodore is going to be adjusting those workloads at the pod level. So Commodore will not be, and this is how it works by default. Commodore will not be impacting the actual deployment itself. It will be automatically adjusting the pods themselves and the resources for those pods, which will not trigger a sync from those GitOps tools that you are talking about, largely because those GitOps tools are looking at the deployment level or daemon set or whatever. The other thing to consider is Argo, for instance, does have the capability to ignore differences and things of that nature. So we can do things like have Argo control CPU and memory for an initial deployment, and knowing we are allowing Commodore to adjust those values as needed. I think we all know like GitOps, it's we want everything to be in our single source of truth, which is our manifests, and most times that is true, but I think it's pretty common in the Kubernetes space for things like controllers and different operators to have some sort of control over parts of our manifest, at least outside of source control. And then the last question about, do you also integrate with BKE and EKS? I guess would probably ask a question with that one is as to when we say integrate, are we talking specifically about costs? Are we talking about Commodore in general? I'll probably assume costs, since that's what we're here for. So yes, we do integrate with GKE and EKS. I think we know Carpenter is an open source tool, but in my experience, mostly employed on EKS clusters. So I think that's very much a thing. And then GKE can also run Carpenter. So absolutely right. We can integrate in both of those levels, including AKS as well. Yeah.
Awesome. Great questions from the crowd. Thank you, everyone in the crowd. Kelly, any final parting words on your end?
Absolutely. For those of you who ask questions, please check the chat. I sent you my email address. If you would email me your t-shirt size and your mailing address, we'd love to send you a Commodore t-shirt for participating and asking a question.
Awesome. So we will send, as mentioned before, we will send a recording of the webinar. I'd like to give a huge thank you to my colleagues, Kelly and Phil, for doing an absolutely wonderful job. Feel free to contact us if you have any additional follow-up questions, either to Kelly's email or on the website. If you need to contact us, you'll figure it out. I appreciate everyone for taking the time out to be here. Stay safe and have a good one. Cheers.
Hi, everybody. Thank you.